Human design is a system that provides a unique blueprint of an individual's energetic makeup. It draws upon ancient wisdom traditions like the I Ching and the chakra system. Human design states that we are born with a specific energetic configuration. This configuration influences our personality, strengths, weaknesses, and how we interact with the world. A key concept in human design is the aura. The aura is described as an energy field that surrounds and permeates the physical body. This aura, according to human design, carries information about our energetic blueprint. It interacts with the auras of others, creating a dynamic exchange of energy. Human design also emphasizes the concept of type. Your type determines how you are energetically designed to engage with the world. There are 5 main types in human design: manifestors, generators, manifesting generators, projectors, and reflectors. Each type has its own strategy for decision-making and navigating life. Human design uses the principles of electromagnetism. It states that our auras and energy centers, called chakras, operate similarly to electromagnetic fields. Just like magnets attract and repel, our energetic fields are believed to interact with the energy of others. Human design practitioners use the electromagnetic principles to explain concepts like attraction and repulsion between individuals. They explain that understanding your own energetic blueprint can help you navigate relationships and interactions more effectively. By recognizing your own energetic charge, you can make choices that align with your natural energy flow. This use of electromagnetism highlights the interconnected nature of energy. It emphasizes that we are not isolated beings, but rather part of a larger energetic web. Human design draws inspiration from scientific concepts to explain its principles. A fundamental force of nature, electromagnetism governs the interaction between electrically charged particles and encompasses both electricity and magnetism. These forces might seem distinct, but they are actually intertwined aspects of the same phenomenon. Electricity involves the flow of electric charge. This flow is often facilitated by electrons, which are negatively charged particles. Magnetism, on the other hand, arises from the movement of electric charges. A moving electric charge creates a magnetic field around it. The beauty of electromagnetism lies in its elegance and universality. A set of equations, known as Maxwell's equations, describe the behavior of electric and magnetic fields. These equations have been incredibly successful in explaining a vast range of phenomena, from the behavior of light to the workings of electric motors. Electric fields are created by stationary electric charges. They exert forces on other charges. The strength of the electric field decreases with distance from the charge. Imagine a lone electron. It creates an electric field around it that extends outward in all directions. Magnetic fields, in contrast, are generated by moving electric charges. These fields exert forces on other moving charges. The classic example is a bar magnet. The movement of electrons within the magnet creates a magnetic field that we can observe. The interplay between electric and magnetic fields is what gives rise to electromagnetic waves. These waves are disturbances that propagate through space. They carry energy and momentum without the need for a physical medium to travel through. Electromagnetism in action, everyday wonders. Electromagnetism is not just a theoretical concept confined to physics textbooks. It is the driving force behind countless technologies that we rely on every day. Electricity, which powers our homes and devices, is a direct manifestation of electromagnetism. The flow of electrons through wires generates the electrical current that illuminates our cities and runs our computers. Magnetism plays a crucial role in electric motors, generators, and transformers. Possibly a connection of principles found in human design. Electric motors convert electrical energy into mechanical energy, powering everything from fans to electric vehicles. Generators work in reverse, using mechanical energy to generate electricity. Transformers are essential for regulating voltage in electrical grids. Beyond these familiar examples, electromagnetism is at the heart of more sophisticated technologies, such as magnetic resonance imaging, or MRI, in medicine and particle accelerators in scientific research. Electromagnetism's impact on our lives is profound and ever-expanding. The electromagnetic spectrum, unveiling the unseen. The electromagnetic spectrum encompasses the entire range of electromagnetic radiation. This radiation travels in the form of waves. These waves are characterized by their frequency and wavelength. Frequency refers to the number of wave cycles that pass a given point per second. Wavelength is the distance between two consecutive peaks or troughs of a wave. These two properties are inversely proportional. Higher frequency waves have shorter wavelengths, and vice versa. The electromagnetic spectrum is vast, spanning from extremely low-frequency radio waves with wavelengths spanning kilometers to incredibly high-frequency gamma rays with wavelengths smaller than an atom. Visible light, the portion of the spectrum that our eyes can detect, occupies a relatively narrow band in the middle. Frequency, wavelength, and energy. A cosmic dance. The energy carried by an electromagnetic wave is directly proportional to its frequency. This means that higher frequency waves carry more energy. This relationship is fundamental to understanding the diverse properties of electromagnetic radiation. Radio waves, with their low frequencies and long wavelengths, carry relatively low energy. This is why we can safely listen to the radio without any harmful effects. On the other end of the spectrum, gamma rays, with their extremely high frequencies and short wavelengths, are highly energetic and can be dangerous to living tissue. The energy of electromagnetic radiation determines how it interacts with matter. Low-energy waves tend to interact weakly, often passing through materials with little absorption. High-energy waves, on the other hand, interact strongly and can be absorbed, reflected, or scattered by matter. The behavior of waves: reflection, refraction, and beyond. Electromagnetic waves exhibit a variety of behaviors that depend on the properties of the medium they are traveling through. Reflection occurs when a wave encounters a boundary between two different media and bounces back. This is how we see our reflections in a mirror. Refraction happens when a wave changes direction as it passes from one medium to another, like light bending as it travels from air into water. Diffraction is the bending of waves around obstacles or through narrow openings. This phenomenon is why we can hear sounds coming from around corners. Interference occurs when two or more waves overlap, resulting in a combined wave that can be either larger or smaller in amplitude depending on the relative phases of the waves. Understanding how electromagnetic waves behave is crucial in fields like optics, telecommunications, and astronomy. It allows us to design lenses, antennas, and telescopes that manipulate and detect light and other forms of electromagnetic radiation. The visible spectrum, a window to the world. The visible spectrum, the narrow band of electromagnetic radiation that our eyes can perceive, is of particular significance to us. It is through this window that we experience the beauty and diversity of the world around us. Each color within the visible spectrum corresponds to a specific range of wavelengths and frequencies. Red light has the longest wavelength and lowest frequency, while violet light has the shortest wavelength and highest frequency. Our perception of color is a result of our brains interpreting the different wavelengths of light that enter our eyes. The three types of color receptors in our eyes, called cones, are each sensitive to a different range of wavelengths. The combined signals from these cones allow us to perceive the full spectrum of colors. Electromagnetism, unifying technology, and metaphysics. Electromagnetism stands as a cornerstone of modern physics. Its principles underpin our understanding of the universe, from the smallest subatomic particles to the largest cosmic structures. It is the force that binds atoms together, governs chemical reactions and allows stars to shine. Our technological advancements are intricately linked to our understanding of electromagnetism. From the early days of electricity to the development of computers, the internet, and wireless communication, our ability to harness and manipulate electromagnetic forces has revolutionized our world. Beyond the realm of technology, metaphysical systems like human design draw inspiration from the principles of electromagnetism. While these systems may not adhere to the rigor of scientific inquiry, they highlight the interconnected nature of energy and the subtle ways in which we interact with the world around us. Whether we approach it through the lens of science or seek to understand its metaphorical implications, electromagnetism remains a captivating and fundamental force that shapes our universe and our understanding of it. Thank you for watching. If you're ready to explore the fusion of science and spirituality for yourself and in your own life, visit our website at www.fusionofknowledgetv.com.